Hey guys, Rich here with High Caliber Carpentry. Don't do what I just did, which was assume. We're working with the roof pitch right now, and we know that a 12 by 12 is 45-degree angle. And so I assumed that a 6 by 12 would be half of a 45-degree angle of a 12 by 12 and would therefore be 22.5 degrees. I'm going to show you how I was wrong and how we fixed this before it turned into a major ordeal on home. So the easiest way that you can do this is what Michael just did. Again, here's a 12 by 12. So let's say this is your 12-inch rise by your 12-inch run. So that means for every 12 inches of run horizontally, vertically you're covering the same distance up. So a foot in, and your roof also covers a foot up. So this would be your roof pitch right here, your roof slope, and that would be a 12-12 pitch. 12-12 pitch, which would then equal out to be a 45-degree angle. So that's our point of reference. That's what I was using. So I assumed that, again, that it was going to be a 22.5 degree angle. I was wrong. The easiest way that you can do this is let's scale it down like what Michael did on this 2x4. And we know that a 2x4 is 3.5 inches wide by however long. So we take 3.5 inches and we assume that will be our 6 side. Like we're working on a 6 by 12 pitch now. Let's assume this is a 6 by 12. So we take the 6, and it takes 2 6s to get to 12. So we also multiply the 3.5 by 2, and that gives us 7 inches. So the 7 inches would be our scaled down version of our 12. So now this is a 6/12 pitch in a 7-inch by 3.5-inch span. The easiest way to do this, other than using the law of sines, is to get your square right there on that line and pivot, and then make your mark at that 7 inches down here. So we've already made our 7-inch mark down here. We're cutting that line, and then we come over here to the square markings. We're reading 65, 64, 63, roughly 63 and a half right there on that edge. I've already done the math for us over here. So 90 minus that 63 degree angle gives us 27 degree. And since that's actually 63 and a half, it would be 26 and a half degrees. And if you do the law of sines, it comes out to 26.56. So 26 and a half degrees is a 6/12 pitch. Now, in order to do this, if you didn't know how to do that in the first place, but just going through the trigonometry and showing you how trigonometry coincides with carpentry, we're going to use the law of sines to do that with. So let's say we have our 6/12 pitch here, we have our 12 inches here, we have our 6 inches there, and we have an angle of A that we're trying to find. So let's say 6 is our side A. What would we use this one as? Okay, so the hypotenuse is our side B, angle 90 is our angle B. And we do the math to come out with 13.42. So B equals 13.42 inches. Again, here we take A squared plus B squared equals C squared, and then we square root C squared to come up with 13.42 is our answer, right? So now we transpose that into an equation, sine A equals sine B equals sine C. I'm sorry, sine A over A equals sine B over B equals sine C over C. There you go. So now we're going to use A and B as our components. So we have sine A over big A equals sine little b over b. So our sine A is what we're trying to find. Our big A, so let's just rewrite the equation, sine A over 6, because A equals 6, equals sine B, which is 90, sine little b, which is 90, over big B, which is 13.42. Great. Now we cross multiply, because let's do that. It's 13.42, and then 13.42 over here. So whatever you multiply on one side or the other, you got to do it on the other side. That's why we cross multiply. Okay, so we have 13.42 sine A equals, multiply 6 into this one, 6, and sine 90 is equal to 1. So I'm just going to put 1 in parentheses here to shorten our equation. right, so now we take 13.42 and we divide it out of this, out of sine A, because we're trying to find A. We're even going to separate the sine out of here, and I'll show you how to do that. So we have that sine A equals 6, because 6 times 1 is 6, so we just take the 6 divided by 13.42. All right, now we got to get the sine out of here, and the way that we do that is when you divide sine out, it will look like this, divided by a sine. And I mean, I guess you could do that, but the easiest way to do that, actually, you divide out sine there, and then you divide out sine on the other side. What you do on one side is what you do on the other side. So now we have our A isolated, and we take our sine inverse. And sine inverse, all of sine inverse is, the rule for sine inverse is 1 over sine. And that's what we got right here. So we take sine inverse, and we multiply that by 6 over 13.42, and you'll see that A equals 26.56 degrees. Great. So even though the 0.06 is a little more than half, we're still going to go with 26.5. If you wind up at 27, not a deal breaker either. But again, that was the easier way of doing it. Scale it down for yourself, or you can come over here and do the law of sines and get it more mathematically correct, which will give you, these smaller numbers. If you're an engineer, that makes a difference. If you're, rough framing a house, not so much. But you've got to have the 26.5. You've got to have that close. I had, again, 22.5 degrees. That is not close at all. So it was very critical that we got that figured out. Here, let me show you this. Here's how much of a difference 22.5 degrees looks like on a house compared to 26.5 degrees. So this is our 22.5 degree line, and this is our 26.5 degree line. And gosh, what would you say? That's be about a 4-inch difference right there. So that's a lot. So make sure that you're using the right formulas, that you're using the right knowledge and skills to get what you need to done. Appreciate it, guys. Go out there, do great things, and measure once, measure twice, cut once. There you go. Measure twice, cut once. See you guys.